What we have here is a breadboard. Breadboards come in different sizes, but they all look like what you see here. They might be smaller or larger, but they have similar wiring arrangement, interconnect arrangement. A breadboard is a simple device. It has a large number of holes, and these holes are spaced just right for us to be able to take components such as a microcontroller that are in the dual inline DIP package and plug them right into the breadboard. The second thing a breadboard does in addition to accommodate components is that internally it has certain wiring structure. Certain things inside this breadboard are wired together. So, for instance, the entire row that ends in this channel in the middle is basically a separator. What that tells me is that this row of holes are all internally connected. It's as if they're jumped. There is a jumper underneath that connects every hole to the next one. But that connection does not cross over the channel. The channel is basically an indicator to me that the connections on this side are not connected to the connections on the other side. Also, the connections on one row do not jump over to the connections to the next row. So two adjacent rows, two holes on two different rows are not connected internally. So column-wise connected, row-wise not connected. Certain other areas of the breadboard might have a slightly different interconnect. So the channels in between this wider sort of strip, so the ones that are in pairs, these have just the opposite kind of connection. Everything along the column is connected, but along the rows, they're not.
And how do you know that?
Well, this is the common layout of breadboards. So it's sort of the de facto standard for how breadboards are. Certain breadboards actually have a blue line or a red line running across all of the internal interconnects, so you can visually very quickly identify which holes are connected to which other holes. And some other breadboards actually come with a little manual that will also describe this in text, so you can read it and make certain how things are connected. For certain, you should also verify things on your own. So if you have a multimeter, you should learn how to test for continuity. And you should be able to also do some probing of your own to verify that you have a good understanding of how the breadboard works. Lastly, remember that the breadboard is designed to accommodate dual inline packages. So for instance, this microcontroller that you see right here has 40 pins, 20 on the right and 20 on the left. The breadboard is designed so that the row of pins on the right and the row of pins on the left sit across this channel, this middle channel. And the structure of the breadboard is such that no two pins of the microcontroller are shorted out. Because if that were to happen, then the microcontroller outputs would be connected together, and that's not something we want to do. So in this case, based on what I just described, as you can see, none of the pins of this microcontroller will be internally connected on this breadboard as it's inserted in there. Because for instance, if we take this pin, you can see that it is internally connected to a particular row here, but that row doesn't span over to the next side, so this pin is not connected to that pin. Likewise, as I told you earlier, each row is independent of the next, so this pin is not connected to that pin because they're on different rows. So if you were to actually just examine that for a minute, just stare at it and think about the internal structure, you'll realize that none of the pins of our microcontroller are now shorted out, and that's what we want to avoid.